Right. This one is find the arc length of y equals square root of 1 minus x squared, negative 1 to positive 1. Well, that being 1 minus x squared to the 1/2, the derivative is going to be what? 1/2, 1 minus x squared to the minus 1/2. But there's more. What more do I have there? Times negative 2x. Because chain rule. Good thing about that is the 2's cancel, so I've just... let's write it this way. Derivative is, so you'll see why in a second. Let's write it, that would be minus x on top and the square root of 1 minus x squared on the bottom, wouldn't it? Got minus x, that would be on top, but then that would flip over. Let's write it like that. That's the derivative. Okay, so now our arc length is square root, integral of a to b, negative 1 to 1, square root of 1 plus the derivative, which is this, negative x, square root of 1 minus x squared, squared dx. All right, well, square that out. That's usually our first step. What do I get when I square out this nice little expression here? Negative x squared, that's good because that's just positive x squared. And then the square root of 1 minus x squared squared would just be 1 minus x squared, wouldn't it? Okay. What do I do with that, you think? Well, probably go ahead and combine these fractions into one fraction, okay? Get a common denominator. So I would multiply this one by 1 minus x squared, 1 minus x squared, 1 minus x squared, 1 minus x squared. With me? I'm just multiplying this first one by 1 minus x squared, 1 minus x squared. So that would get me, well, it'd be 1 minus x squared plus x squared on top, which, aren't the x squares going to cancel? So I'll just have 1 over 1 minus x squared. Which, separate those out, square root of 1 is 1 over the square root of 1 minus x squared. Which, does that, how we do that? That's sine inverse, yeah. This one works out nicely too. They should most of the time, the ones we pick anyway, usually work out fairly nicely. This is just sine inverse, isn't it? Direct antiderivative, just sine inverse. Negative 1 to 1. So it's sine inverse of 1 minus sine inverse of negative 1. So sine inverse of 1. What angle, so we're looking, sine inverse of 1 equals what angle? So I'm looking for sine theta that gives me 1. What would theta be? Pi over 2. Pi over 2. This one is looking for basically the same, except what angle gives me sine negative 1? 3 pi over 2? Go all the way around? Sort of? Well, it's sine inverse, though. Remember, sine inverse, you operate between pi over 2 and minus pi over 2. Huh? Negative pi over 2, yeah. So your sine inverse, remember, sine inverse goes between You have to remember those restrictions. It goes between minus pi over 2 and positive pi over 2. 3 pi over 2 works, but sine inverse, the actual function, only goes between pi over 2 and minus pi over 2. So it's minus pi over 2 would get you the same result, wouldn't it? So minus makes a plus. It's positive pi. Okay? Now, I do all that to say this. This one actually, let's think about it. So that's the arc length. Think about the curve here, though. What shape is this curve? In a semicircle? -1 to +1. That's a circle, semicircle, radius 1. And I'm finding the arc length, which also is known as, for this case, circumference. And circumference is 2 pi r for a full circle. It's half of 2 pi r, isn't it? For a semicircle, pi r. My radius is 1. We already knew the answer here. It's pi. We just checked our answer, I guess I'd say. Yeah, it works out. Okay? All right. Now, these, like I said, were nice functions, or they did wind up to be something nice for the arc length. What if they don't turn out to be so nice? Well, there's going to be a lot of those that do. And so let's just hit one of those real quick. Yeah. Let's say we've got here's what they'll say. I'll just go ahead and phrase it like they'll say. All right, let's use Simpson's rule, n equals 8, to approximate the arc length. Y equals 1 over x. X is between 2 and +4. Simple function looking like, right? 1 over x. Derivative, well, since that's x to -1, derivative would be minus x to -2. Well, let's see what happens. Arc length is the integral 2 to 4, square root of 1 plus the derivative squared, minus x to -2 squared, dx. That turns into integral of square root of 1 plus x to the -4 dx. Yeah, there's not just not a whole lot. You can try some of the tricks we've done, but I want to say that's just an impossible one to do. So just 1 over x, that simple looking curve, to get the arc length, you can't really do it directly. So that's why, yeah, we approximate it. Approximations give you, if you're just interested in the length, they give you a pretty good approximation. So this is a good time then to review our approximations. How do I do Simpson's rule? Well, that's also known as Simpson's 1/3 rule. And so this integral is approximately then delta x divided by 3 times, let's see, the way we wrote it out, f of x sub 0 plus, what was the coefficient for Simpson's after the first one? 4x sub 1, f of x sub 1, plus, what was the next one? 2. It alternates in between 4 and 2. F of x sub 2 plus 4 f of x sub 3. till you get to the end, which would be f of x sub 8 in this case. Okay? So what are my x sub 0s? Well, x sub 0 is 2. X sub 1 then would be 2 plus delta x plus delta x. B minus a over n. So it's a fourth, 0.25. So this would be 2.25. X sub 2 is in 2.5. X sub 3 is 2.75. Blah, 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 right? So in my case here, it's going to be delta x over 3 and f of x sub 0, so it'll be f of 2 plus 4 f of 2.25 plus 2 times f of 2.5 plus 4 times f of 2.75, 2 f of 3, 4 f of 3.25. It's good. I like to write them all out so I can see. 2 f of 3.5 and 4 f of 375, and then last f of 4. Okay? We're going to use that to approximate. Now, here's the next big point. Do I use my original function? Why don't I use the original function? F here, f of x is not, when I use it here, f of x is not the original function. Why not? That's not the integral I'm doing. I'm doing the integral of this. This is the f of x. So be aware there. Even though my original function is 1 over x, the f of x I use is what I get here for my integral, for the arc length. With me? So let's plug that in and see if we can get what I got before. All right, so the square root of, plug that into y1, square root of 1 plus x to the minus 4. And then let's go back and calculate. So delta x is 0.25, so it'll be 0.25 divided by 3 times y1 of 2 for y1 of 2.25 plus 2 y1 of 2.5 4 y1 of, where am I, 275? 2 y1 of 3 and 4 325. Two, how many more I got? Who chose 8? I guess I did. 3.5 and 4 375. And 2, no, just y1 of 4. Nobody checking me? I did this before, so I should. Yes, 2, 0, 1, 8, 1. Approximately. So the length of that curve, 1 over x, which I know what that looks like. 1 over x looks like that, doesn't it? So from 2 out here to 4, almost a straight line, but not quite. It's about 2.01. That length right there. Approximately. All right. How's that? Not too bad?